In this video, we're going to be going over Lab 6 and what all that entails. Right, so you were given this file here, and inside of this file here, it has, which is your class activity 9, which is part 1. So we have our imports of a module, the random module, and the time module. We have defined our symbols, our constant variables. That's why they're in all uppercase. All of your constants should be in uppercase. And in particularly, these are going to be the emojis that we use here. And then we have our dictionary of available pets to choose from. In this case, just a dog, cat, and bunny. We have our defined color for status display. So we have critical, moderate, health, reset. We've also have our hunger, happiness, and health. We assigned it initially 5 for those of, and then the next function we have here, above this function, we have a constant variable to create the size of the grid to be 7. We have the function called create grid. And inside of this function here, we have our list that we've created, and we're going to have a list within a list. So this is going to be a 2D list to display our grid. So we have our initial grid, which is open close square brackets. Then we have our for loop here that goes from range 0 to our grid size, which is 7. So it goes from 0 to 6. Then here we have our row data, which is the inner list. So that's where we get our 2D list here. And we have our other for loop that is going to say for every column in that range going from 0 to the grid size. Then what we say here is if the row is 0, or the row is equivalent to grid minus 1, or column equals 0, or column equals grid minus 1, then we're going to append the walls there. Otherwise, we're going to add in all of the floors. And essentially what that is it's just the initial marking of your, let me move this so you can see it. It's the initial marking of your grid. So when we zoom in here, we see that with row being 0 and grid minus 1, we have our walls all around the perimeters, and the rest, which would be the initial grid, will have all of the floors initially. Okay. And then what we do is we're going to append the walls, we're appending the floors, and then we are appending the row data into our grid. And this is what makes that 2D list at the very end. Then where we're going to return that 2D list as grid here. So whenever we call this create grid function, it's going to return a 2D list grid. Then we have the user instructions. This is just what the user sees. So I've assigned it to the variable message. Then afterwards here, this is prompting the user. So we're printing out to the user, welcome to the virtual pet simulator, choose your pet. We're using our while loop, and we're saying while true, you choose any value from 1, 2, or 3, meaning dog, cat, or bunny in this case. And then here on line 105, it says if the choice is inside of that list, which means it's either string 1, 2, or 3. And the reason we're doing that is because input does return it as a string. So it's checking to see if the choice of the user entered in is a string of 1, 2, or 3. Then if it isn't that, then it's going to break. Otherwise, it's going to showcase that that was an invalid choice and you have to enter in 1, 2, or 3. The next part of this that we're actually going to be looking at is we want to assign the pet symbol. So whichever item the user entered in based off of their choice. So we're taking the user's variable and we're going to be using that value to access the pet list there, which should be, or the pet grid, a dictionary here, which should then assign the value symbol to pet symbol here. Then we ask the user what you would like your pet name to be. So we're stripping away any spaces, and we're also going to capitalize the pet's name. When the user types in that input, it's going to get assigned to the variable pet name. Then what we're going to do is return multiple outputs. We're returning the symbol of the pet, and we're returning the name of the pet to whatever function calls the prompt user. That is what the prompt user function does. The next thing we're going to look at is step 7. So when I told you guys to kind of look through this code to see if you had any questions about it before you start adding to it, this is kind of what I mean when we're kind of going through each function, making sure we understand what's happening. So here we have assigned or created an empty list called positions, and this is where we're actually going to generate all of the available floor positions inside of the house, and we're going to be excluding the walls. So that's why we start with 1, because it's not going to be the 0 perimeter, and we're going to do grid size -1. So it's going to be 7 minus 1, which is 6. So it's going to go from 1 to 5 here. Remember, with range, it only goes from whatever value you have as starting and up to this value of stopping, not including that value. So here we're going to be using our two nested for loops here. We're going to say for every row inside of the range of 1 to 6, basically 1 to 5, and for every column in the range of 1 to 6, basically 1 to 5, we're going to append those positions, and we're appending it as a tuple. So we're going to place inside of this list a range of coordinates from our grid that is going to be the row and column within that grid. And then here in this case, when we use the random module to access the shuffle function, we're just passing in that positions list, which just has a range of coordinates from that grid, and it's going to shuffle it and move it around and make sure that it's not all the same way that we had originally. Then it's going to return that list of coordinates, that list of tuples there. So that's how we generate the positions here, and we place them, we allow for randomization of the positions. The next part here is using the place object. So we have this function and we're passing in 3 parameters. We're passing in the grid, we're passing in the positions list that we have here, so a shuffled list, and we're passing in the pet symbol. So in this case here, we also see that we're using the global keyword, which means that we're going to be updating the pet's position. We're also going to be updating the food position. So in this case here, whenever we use a global, whatever values they were originally now will get updated since they were globalized. So the pet position, when we pop our list of tuples here, it's going to give us, in the pop function, just gives us the very first item in that list. So we're going to pop it into pet position, and that gets assigned to pet position, and it will update because of this line here, the global pet position, and we're popping that here. The next line is we're going to pop the next position after the original pop, and that's going to get assigned to food position. And we're going to do the same for bed position and toy position. So it's going to be the next item that gets assigned or popped off that positions list and gets assigned to bed position and toy position. The next thing that we have here is actually using a list of obstacle positions here. We're going to be adding in 3 items like we have in the actual image. So we want to be able to randomize those positions, which we have already done that, and we're going to add obstacles within that list. So we created an empty list up here. We're using a for loop to iterate through ranges of 0 to 2, which just means it's going to be 0, 1, and 2. And what we're going to be doing is just popping at each position 3 different positions of where the obstacles can be, and we're going to be appending that to the obstacle list here. The next thing we have here is we're going to be using our grid, and we're going to assign in our grid the food position, and we're using 0 and 1 because remember, what we popped here is a tuple. It's a coordinate list. So we have, for example, X and Y here, which is accessed by using For example, if we were to have positions, or in this case, pet underscore position, and we were to access X, we would first have it be 0. And then if we wanted to access Y, or whatever value that is, we would have that be 1 because it's a tuple being stored there. So in this case, we're doing the same thing. We're saying in the grid, in that first index or wherever that index is, we're going to put the food position 0, the X coordinate of that, and the Y coordinate of that there. Then we're going to assign to that the food bowl. So that's where that first, that's where the food bowl will be, wherever food position is in 0 and 1. Same thing here with bed. Wherever bed position is at 0 and 1, that's where we're going to assign the bed emoji at the top to. Same thing below here with the toy position. Wherever that toy position is when the tuple of 0 and 1, we're going to assign the toys there. So I hope that makes sense. The next thing that we're actually going to be looking at is going to be how we place the objects into the grid. So because remember, we have a list of obstacle positions and it has 3 items in there. Now we're going to use that same for loop and we're going to say for every obstacle inside of that obstacle position there, we are going to update the grid and we're going to assign an obstacle to each position that we see in that tuple for each time. So it's going to iterate through that list and assign to wherever that coordinate is that we popped in index 0, 1, and 2 of this list. Then it's going to assign an obstacle there. And our obstacle image, I believe, is a chair. So then the next thing here we see is we want to place the actual pet symbol that the user picked on there. So we're going to use the pet position that we popped up here, and we're going to assign that pet symbol into the grid here as well. So I hope that makes sense to you. If anyone had any questions about placing objects, please let me know. I'd be more than happy to go through it with you in one-on-one time. All right. Then the next function that you have here within the code is just to get health color. So we're passing in the health, and at the time, it's actually 5 because we already signed it. We had a global variable of health being 5 at the top. And that was the initial state of health. So it's saying if 5 is greater than or equal to 8, which is not, return green. Elif 5 is less than 8, it is, or it's greater than or equal to 6, then we're going to return yellow. Otherwise, we're going to return red. So that's the get health color function. The next part of this that we're going to be looking at is just displaying the status. So this display status takes in 2 parameters, the pet symbol and the name of the pet, which is what the user picked at the very top. We are also here going to display, this is your pet status. We're making a call to our get health color function here, passing in health, which is a global variable. So you notice that it doesn't give us an error saying that it's not in here. It's a global variable. And then whatever gets returned here, meaning red, yellow, or green, it's going to be assigned to the variable health color. And then here we're just going to display it out. The next function that you're going to look at is just displaying the grid. So this takes in the grid as a parameter, and then we use our nested for loop to iterate through that grid because it is a 2D list. We have row and column. So for the first one, we have for every row inside of grid, we're going to say for every cell that's inside of the row, we're just going to left align it to 2 spaces and make sure that at the end we have a space between each cell, which is just each square. And we're going to print out that information. So that's how we get the display of our grid here. And then we're going to place the print statement afterwards to make sure we constantly have a space and a new line between each row and column there. And then we have our main function here, which we call the user instructions that we had at the top. We call the prompt user function that returns the pet symbol and the pet name. We call the create grid that returns the grid. We call the generate positions that returns a list of positions. Then we call the place objects passing in the grid, the positions, as well as the pet symbol. And we display the grid and we display the pet status and the pet symbol and the pet name. And then we just run the main function. So this is what was given to you. Now what lab 6 is asking us or inquiring us to do is the very first thing we want to do after you review the current code. You're now going to create a function called respawn food and respawn underscore food. And in this function, we're going to refresh the location of the food each time that our pet eats it. And we are also going to scroll to a blank section below, and we want to just below our previous code, add some sort of header. Just step 11, respawn food. We're going to define the function, and it seems like we're going to be passing in grid into that function. Inside of the function, we want to declare the food position as global so it can be updated. So we see that we're going to have to update that food position. Then we're going to create a list of all available coordinates inside of the grid where the cell does not actually contain a wall or obstacle or toy or bed. And then we're going to use a random choice. We're going to use the choice function in the random module to pick one of those empty floor spots as the new food location. And then we're going to place the food bowl symbol at that position inside of the grid, update the global variable food position to the new coordinate. Then we're going to make sure that the food reappears in a new random spot every time the pet eats it. So the first thing first that we're going to do is open up Visual Studio Code, this over, and right underneath here is going to place a header here. And then this one, I'm just going to type in step 11, spawn food. And the first thing it asks us to do is define this function. So we're just going to define respawn food. And with this, we know that this is going to take in a grid. So we're going to have grid as the parameter. The instructions also said that we're going to be updating the food position. So that means that we're going to need to have our global keyword here. And we're just going to, let me make sure that this is tagged in correctly. Okay. Then we're going to be updating the food position. So we're going to have that there. The next thing it says for us to do is for us to have, for us to create a list of all available coordinates inside of the grid where the cell does not contain a wall, obstacle, toy, or food. So in this case here, we can literally create a list called available. And then the next thing we're going to do is we're going to just do what we can do to first start off. So if you don't quite get everything to start off with, it does say that we're going to have to use a nested for loop to kind of go through the grid. So we can just have for R in range of, and we know that we're going to have to put something in there. And then we're going to have another for loop here. We're going to say for C in range of. And so we have our nested for loop here. Again, you've done what you could do. I believe the next thing that it says something about using random choice to pick one of those empty floor spots. And we also need to update our floor bowl. So what we're going to do now is just fill in the gaps. So we've already defined the function called respawn food. We've passed in the grid. We've already inside of the function declared a global variable food position so that it can be updated. We know that we have to create a list of all available coordinates inside of the grid where the cell does not contain a wall, obstacle, toy. So we know that we're going to have to check to see if wall, obstacle, toy, or bed are inside of some list here. So in that case, I can also create an if statement, and we will figure out where to place it once we have done an if statement. So we're going to say if grid, and we know that we need to have two open closed square brackets, not in, and we know that we're going to need to have wall, obstacles, toys, and beds, and I think walls is actually S in mine. So in this case here, we know we already have a check here. So we have some form of setup. Even if you have no idea how to go about doing this, just do what you can do. Now, the next part of this, we're going to be filling in the gaps to actually properly do this. All right. So in this case, we have our empty available list. We know that we have to go through range, and we know we don't want to hit any of the walls. So what should our range be? If we're just like even just going to see what other ranges there were available in the generate position. It started at 1 and went from grid size to -1. So if we're looking at past information. And then we also look at the instructions for um, lab 6, we're respawning. We create a list of available coordinates inside the grid where the cell does not contain a wall, obstacle, toy, or bed. Use random choice to pick one of these empty floor spots as the new food location. And we're going to place the food bowl symbol at the position inside of the grid and update it. All right. So in this case, we know that we want to go from 1 to the constant variable grid size -1 because we don't want it to actually be going to the wall. And we're going to get rid of the pass here because we don't need it. Now the next part is the 4C in range. We're going to do the same thing because we only want it to go up to a certain point. So now we have 4R in range of 1, grid size -1, 4C in range of 1, grid size -1. So this is great. It goes throughout the whole entire grid, but not on the walls here. So we had that process. The next thing is we now need to say as long as it's not inside of that, then we're going to actually want to check. So this if statement is going to be in the inner loop here, because that's the way for us to be able to access R and C. So in this case, we have for every R, which is row in this case, lowercase r, and for every column. So now we're going to put the C there. That's not inside of the wall, obstacles, toys, or bed. Now we're going to end our if statement. And we know if we want it to be inside of the available list, we have to use what built-in function. We're first going to have available, then we're going to say what? Pop, sort, append, reverse, insert, extend. We're going to actually use append. So we're going to append those positions there. So we're going to make sure that it's a tuple like we did above. And we're just going to say R, comma, C. So we are appending the row and column to the available list. Now, the next part of this, now that we've gotten the, tuples within that available list, the next part of this is actually going to be us randomly picking a choice to assign to our food position. So we know we're going to have our food position that we're going to assign a random uh, coordinate or tuple to. We also know that we've imported random at the very top. So we're going to use that and we're going to access some of their built-in functions. Now in the instructions itself, it says to use a random choice to pick one of those empty floor spots. So in that case, we're just going to use choice. And in order to find out which one of those we're randomly going to use, we're just going to pass in the list that we appended the coordinates to. Because the coordinates know we're not going to hit the wall, the obstacle, toys, or bed. These are just going to be free spaces. So we're going to pass in the list available. And it will pick a random choice from that list and assign it to the food position. Now, because this is a tuple here, we have R comma C, which is a coordinate here. We know that we're going to access it in the same way that we've seen in the above code that was given. So we're going to use the grid, open close square brackets here. And we know that we're also going to be assigning the food bowl. So again, do what you can do. Now we're going to fill in the gaps. So we have the grid, we have the food bowl. What's next? The next thing is to use our food position. The first item, which would be in our case R, we're going to put 0 to access R. And we're going to do the same thing over here. Food bowl, food position, open close square brackets, and we're going to do 1 to access C. That's how we're able to access each item within that tuple. We have that open close square brackets 0, open close square brackets 1. And then we already have assigned the food bowl, which is a literal image of the food here, to that specific position. And that's what is required for the respawn function here. So what we're going to do in main, actually what we're going to move on to is the move pet function really quickly. Because with this, it requires us to see it updated each time. So we'll need to be able to move the pet. So we'll begin testing in a moment. But what you can do, you can also just print call position. And we're going to call respawn grid a few times here. So I'm going to just 3 times. And to run this file. Okay, first things first. Oh, but first we'd also want to display the grid each time too. Okay, so below here, we're just going to have this be 1 for the dog. The pet's name, I'll make it Robin. And then we see here, when we respawn the food, we have it here and at position 3 and 5. So, 3, 4, 0, 1, 2, 3. 4. So it's going to be here, position 1, 2, 3, 5 here. And then we see the other one, 2 to 5, which is right here. Then we see the other one, 4 to 4, so it's right here. Usually what will happen is when we update it, the pet will just eat it and we won't see the rest of them. But this is where we see that the respawning worked and it's at different positions each time. So we know that the function does update, and so we're good here. We can get rid of this line for right now. And we can, if you want, you can keep this or you can comment it out. So the next thing we're actually going to look at is going to be the movement. All right. So in this next section, it's kind of one of my favorite. We're going to be defining the move pet section as well. All right, so then we have this function moves your pet around the grid, prevents walking into obstacles, and updates the stats after every move. We're going to add a header and we're going to label it. And I'm just going to copy this because I also kind of like having emojis and stuff. So I'm going to copy that header in, and it's step 12, where the pet movement and interaction. We're going to define a function named move pet. Seems like we're going to pass in a direction. We're going to pass in a grid. We're going to pass in a pet symbol and a pet name. So inside of this, we're going to declare your key global variables: pet position, hunger, happiness, health, and food position. Extract the current row and column from pet position and assign them to row and column. Initialize new row and new column to start as the same values. Then we're going to use conditional check. So this seems like a lot. However, we're going to break it down. I'm not going to read all the instructions right at the present. We're just going to start here from this point here. So the first thing we're going to do is make sure that we define the function here. Again, don't let the words be the thing that throws you off, because that's exactly what it does, for at least beginning programmers. Try not to be too overwhelmed with it. So we're just going to have 12 here, and this one is going to be called the move pet function. It's the same, so we're going to copy that, paste. All right. All right, so in this case here, the first thing we want to do is define the function. So we're going to define the move underscore pet function here. And we remember that this is actually going to take in the direction from what the instructions say, the grid, the pet symbol, which makes sense. We have to make sure that we can see the pet symbol move, and the pet name. So now that we have this process here, we're going to go back to the instructions and see what all else it asks. So we've defined the function, taking in the direction, grid, pet symbol, pet name. Inside of it, we're going to declare your key global variables. So that means we're going to be updating the pet position, hunger, happiness, health, and food position. So we're going to do all of that by using the global keyword. So we're going to do the pet position, hunger, happiness, health, and the food position here. All right. So now that we have this, the next thing that it requires us to do is for us to extract the current row and column from the pet position and assign them to row and column. So when we see this, Again, like when we went over the code with me's in the past, I said, look at the wording of things. Pet position, we know holds a coordinate of X and Y position or row and column position. If it's asking us to extract that for the row and column, we could do one of two things. You could either do the pet position 0, assign it to row, pet position 1, assign it to column, or we can do this process here where we have row and column and we just assign pet position to it. And so what it does is it takes the position 0 for row, position 1 for column, and it is based off of order here. So that was that step of extracting the row and column. Again, you could do row equals pet underscore position and make that be 0. And then column being pet underscore position and make that be 1. If you're more comfortable doing that, then that's perfectly fine as well. Either or works, just finds your own programming style that works best for you as you're learning. Okay. So now that we have that part, the next thing that we have to do is now we need to initialize the new row and the new column to start as the same value. So we're just going to reassign these values to these new variables here. So we're just going to do, I'm going to do it below here so you can see this. We're going to get rid of pass as well because I will forget. One. All right, so here we're going to do new underscore row, new underscore column, and we're going to assign row and column just like that. So they're all going to be assigned to the same thing. We're assigning the row here, column here. In the same way you have this, you can do this on the same line where row will be assigned a new row, column will be assigned a new column. Now, the next part of this that we're actually going to do is we want to use conditional check. So this is where we're going to get into the if-else statement. So if, elif to translate movement. So inside, and I know that for the most of you guys that play games, you understand the A or the WASD. For me, I only just started understanding that as my husband's been teaching me things here and there. So W on your keyboard will move up, and that's just going to decrease the row by 1. And I will kind of try to visually show you this here in a moment. Let me pull up another lab screen real quick. Let me pause the video so it doesn't take up too much time. So what I'm first going to do is actually copy this function header here so that we can test it out so you can actually visually see what this all means. So I'm going to call it here real quick as we set up. And for the first one, direction, I'm just going to type in W because right now it doesn't matter. We're not using it yet. For the pet symbol, I'm going to make it the same as what is inside of this main function here. And from the last video, hopefully if you saw when I created this, we're just going to use PS for pet symbol and with a capital S and PN for pet name. These are not the best naming conventions. In fact, you'd want to keep them the same, but I believe for that video, I was showing you the difference between local variable and global variable. So we're going to keep it the same here. So what it's going to do is now call our move pet function here. I'm going to separate the two so I know to delete this part of it. And then what we want to do here is print out the row and column. So move up. We're just going to print out the row and column. And I'm just okay. And oh, okay, and save this. All right. So let's run this real quick. We'll see some outcome. Zoom in a bit. And my Windows key, for those of you who are trying to work with Visual Studio Code, how you zoom in with the terminal is you just do control the plus symbol or control the minus symbol. And for Macs, it's the same thing, but I think for you guys it's called command instead of control. So you can zoom in if you'd like in that way. So for this first one here, I'm just going to put in 1 as the dog, and then obviously Robin. And then here we see it's going to be row 1 and column 1. And we see that's exactly where the pet is. I want to recall this again because I need to show the up first. Hopefully it doesn't spawn in the first place there. Okay, great. So we're at row 3, column 2. So when we get into this grid, and I'll show you how to fix this in a moment, there's spacing in there, which we'll get to. But here we see the pet here is at the position 3 and 2. So when we see row 3, we're talking about row 1, row 2, row 3 of the grid. This is row 0 of the grid. So if we look at this 0, 1, we're looking at row 0, 1, 2, 3, 4, 5, 6, which we know for normal people not programming, this is just 1 to 7. So we're looking at, in this case, this one, row 3 and 2, which in this case, we're looking at row 3. And then when we look at column, looking at 0, 1, 2, 3, 4. So I'm not an artist, 5, 6 here. So this is going to be column 2. So we do see here that our pet is at row 3, column 2. So that's its original state. So when we do up 1, you'll notice here that if we decided to move up, let's use a different color for that. I'm going to pause this so it's a bit clearer, so this will be a little bit easier to see. All right, so really quickly, I've kind of readjusted this a bit so that it's easier to see. So in this case here, what we're actually going to be looking at is we have our column that goes up to down. This is column 0. This is column 0. This is column 1. This is column 2, which is where the pet is. And so if we want to move up 1, if right now the pet is at 3, comma 2, and we want to move the pet up, which is using W, that means that the row has to be 2, which means it decreases by 1, and the column is going to stay the same. So we want to go from 3 to 2 to now 2 to 2. So when we move up, it's only decreasing the row. So that's what I mean. If I wanted to move left, which it wouldn't let us because there's an obstacle, but if I did, let's say I did want to move left here instead of moving up. Instead, if we're at 3.2, this left is A. Okay, so I would move left, and we're seeing here it's actually modifying the column now. So if the column was 2 and we're moving left, the column changes from 2 to 1. So now it would be 1, comma, and we would still keep the pet at 3. That's if we're keeping at this, we're starting the pet here each time. Now, the next part of this would be if we're trying to use S and we're trying to move down 1, that means we're going to add 1 to row. So instead of it being 3, it's now going to be 4. So it's going to be 4 as the row, and the column is going to stay the same as 2. You say D, okay. And then the next one is going to be D. So when we do D, it's going to be moving to the right. And it means that we're increasing our column. So the column is now going to be 3. And the row is going to stay the same as 3. That's if this is our starting point. Okay. So that is the kind of structure that we're going to be looking at when we're going through this if-else if statement here. Okay, so that's kind of what I want you to process. Please let me know if you'd like me to explain this again to you in class, or if you want a little bit of a different breakdown. I'd be more than happy to. But that's pretty much the process that we're going to be using. There. Okay. Okay. So in this case here, now that we're finished kind of testing that out, we're just going to first write our first if condition. So we're going to say if direction is equivalent to W. And with this, it's dependent on how you want to process that user's information. So if you're going to be using dot upper, you want to make sure that your conditions here are dot upper. If you're going to be using dot lower, you want to make sure that your W is lower. So in this case, I'm going to be making sure mine is uppercase, and we're going to have that be W. Right. And then again, like I always say, do what you can do first. If you don't quite remember what you need to assign to the new row, we're just going to do pass, and we're going to do elif. Direction is equal to S. Pass. Elif. Direction is equal to A. Pass. Elif. Direction is equal to D. Pass. Then we're going to have our last statement of else. And this would just be some sort of error message. And I can't wait to actually show you guys how you can do that this week. Um, or you can even do that now by using any of the colors. So for this one, you would just do print, and you could say invalid input, and you could even put I believe there's like a warning. Oh, I forgot what color it is. I think it's just red. This one. Yeah, red and reset. So we can actually print this warning out in red. Input, use W, and you want to make sure that you allow the user to see what they need to use. So use W A S or D. And then at the end, you want to make sure you reset. And then here, what we're going to do is we're just going to use one keyword that can terminate this function if they do press some sort of invalid value here. And I'm going, what do you think the returned value should be here? What do you think the keyword we should use here should be? If we want to terminate this, if they press an invalid value. If you said return, you are right. That's what we're going to use here. Okay. So before we move on, we're just going to test this out really quickly. And where we had pass, we're just going to do print. And we're just going to say W moving up. And I'm going to do the same below here just to make sure we remember what we're doing. Again, testing may be tedious for some, but it's actually very helpful while you're going through your code so that you don't mess up, or so that you take your time and you understand what you get and what you don't get. So we have W being up, S being down, A being we're going to move left, and D being we're going to move right. Save. Let's go ahead over here. And in this case here, what I want to do is actually, I'm going to just have direction. And we're going to put W, just A, and this is just for testing purposes. D, some A. Yep. Or I range and I'm going to try to show you the length, direction. Then we're going to call this, and we're just going to make this be I. Or wait, actually, this is great if we, for example, don't know the length, but actually I want to just pass in their direction itself. So instead of using range, what do you think I could do instead? Or I in direction because it's a list. So for every item that's in direction, we're going to just pass an I. So we're going to see it called each time. I'm going to save it and run it. Okay, so we see that we got the WASD, it works, and then we see that our error message prints out perfectly fine. So we know that our logic works, so we've tested it out, and we can get rid of it now, right now. So the logic works right now. We're gonna move up now, and for me, I'm just gonna put an even more pronounced symbol there. Okay. Now, inside of this, if you guys remember, if we wanted to move up, what would be the new row and the new column for this? If we're moving up, it's going to be a new row. So we're going to make sure that the new row is going to be -1 because it's the original value. So you can do minus equal 1, or you can do new row equals new row -1. Both of them work perfectly fine, interchangeably. They're the same thing. And so this is going to make sure that that movement is moving up if we wanted to. If we're wanting to move down, that means we're going to increase the row. So we're going to say new underscore row plus equals 1, or new row equals new row plus 1. So this could work, and I'll just show you that both of them do work interchangeably. So I'll let this one be the one that we use for down. Then for this is where we're actually going to see the difference. If we're moving left, we know that the column is going to be decreased. So we're going to do new column minus equals 1, or new call equals new call -1. And then we're going to do the same thing here for right. The only difference is with new column, we're going to increase it by 1. We're going to do new call plus equals 1, or new underscore call equals new call plus 1. Either or work. We'll just use this one for this as well. Okay. All right. And I think I have to tab this in because it's not tabbed right. Print statement. There we go. All right, so we're gonna save this and we're just gonna put new call here so we can see the new call and then new row here while we're testing. And we do want to make sure that we print that out. So we are going to print out the row and column, but this time we're just going to print out new row column since they're the same thing. And that's what we're kind of keeping track of. So I'm going to go ahead and keep it the same. New column and slash in there. Okay. So now that we have this kind of setup structure here, I want to see and make sure that it actually works well. So we're actually going to see the coordinates when we run it. So we're going to take off these instructions here and we're going to test it up again. All right, so we start off with 2 and 3 as the column here. We start off with 2 and 3. So when we move up, we know that it should decrease the row by 1, and it does, so that works. Then we call it again. It does continue to start with 2 to 3 because that's the original starting state. But when we move left for the column, it now makes it to be 2 instead of 3. So that works well. Then we're going to go down. And now we need to move down. We start off as 2 and 3. It should be that the row is 3. And that's exactly what this is now. It shows the new column is 3. We're moving down. And then the last one here, we're moving to the right. This is the initial point. So we're moving to the right, +1 of the column, and it gets +1 of 3, which is going to be 4. And then lastly, we see that the coordinates is 2 to 3, but because I believe I put K there as the output, yep. So it's just going to say invalid input, use WAS or D. So now that we have that and we know that that portion works and is tested, we're going to move on to the next section of code. So we've finished here with our conditional check. Now we're going to say, if the input isn't one of those letters, we print out error message and we stop the function, which we did. Now we're going to store the grid symbol at the new location inside a variable called target. So it needs to be stored inside of target, and we want to store the grid symbol. So whenever it indicates storing the grid symbol, and we know that this function takes in the grid, we're going to need to be accessing the items in the grid, and we're going to assign that to target. If the target is a wall or an obstacle display, you can't move there, message, and return. Otherwise, we're going to place the old pet position with the floor, update the new cell to contain the pet symbol, and update the pet position to the new coordinate. All right, so let's go ahead and start with this first one. We're going to access the grid and we're going to get our new target. And so, dependent on whatever the user passed in, this target should be updated. So what we're going to do now is align ourselves right underneath our if-elif statement here. And this is where we're going to start writing in our information. Target info. All right, so now in this part here, we're just going to do target. We're going to have our variable target. We know we're going to have to use our grid. And so in this one, because what is keeping track of that grid position and it's updating, we're going to be using the new row and new column here. Because dependent on whatever we pass in, that will be the value. So we're just going to do new row, new column. Okay. So this is now going to be updating the symbol's location. Okay, so then the next part of this that we're asking, and we're going to go ahead and print it out as well, just to make sure. And I'm going to use two backslash n's and two backslash, well, just one backslash n and two backslash t's, which is just going to give us a new line and tab, 8 spaces, because I believe tab is 4. And then we're going to just have target here, like testing here. All right. So then the next part of this that we'll write before we start testing anything else out is going to be our if statement here. Or I mean our updating of, yeah, our if statement rather. Right, yep. So we're going to do if target is the wall or an obstacle. So we know that we could actually place that in the list. So if target in list of wall and obstacles, then we're going to print out you can't move there and return. So that's going to be the next thing we do here. So I'm going to say if target in, and we're going to create that list, walls and obstacles is what it's called. Yes. And then here we're just going to print out some message. And again, you know me. Um, it kind of like images, so we're just going to do oops. You can't move there. New space. And then we're just going to use our return keyword to return out of this if statement. So that's what that section was saying. Just if that target is not, it's not a wall or an obstacle, which we don't want. Like here, I believe it was earlier I was talking about it, but we really don't want the pet to go to the wall or to these the 3 obstacles that we've created here. And again, I will come back to show you how to fix that. Okay, so we're gonna move on to this next part. So we've already done the if part, and you have otherwise. With the otherwise, you can actually choose to use else, or you can just leave that if statement and just do this the rest of the code. So inside of this, we can replace the old pet position with floors. So we're gonna reassign floors to our old pet position, which means that we're going to be using grid and we're going to be using the row and column instead of the new row and column. Then here we're going to update the new cell to contain the pet symbol. So it means we're going to be using here the new column and new row. Then we're going to update the pet position to the new coordinate. So we're going to then say pet position, because remember we used the global key for some of this, the pet position, we're just going to assign to it a new tuple. When it says new coordinates here, you're going to be using that open close parentheses for the tuple. Kind of try to read through some of these instructions to figure out the code behind the scenes and ask questions, which you guys have been doing a very much better job in doing of late. I've gotten quite a few emails, which is great. Don't feel afraid to message me any time of the day. When I see it, I will respond to it. So in this case here, we're going to be using our grid and we're passing in the old row, the old column, and we're going to be assigning there the floors. Because hey, if the pet moved, then we're just going to put in the little symbol there, the front floor there. Now, the next thing we want to do is update the pet symbol on the grid. So we're going to do the grid, open, close square brackets. We know we're going to assign the pet symbol that we passed in as a variable or as a parameter here. All right. And that's going to be at that new row and new column. Then the next thing we're going to do here is we want to now, and this is where the coordinates part sits, we're using our global keyword in this function to update the pet position to where it was originally from their own column that got passed in to now whatever the user decided to type in, either A, D, S, or W. So in this case here, we're just going to do pet underscore position. And because we're reassigning it as a tuple, we're going to have that open close parentheses there. And we're going to do new row, comma, new column. Now this is going to make sure that this is the new coordinates assigned to pet position because that's how we got it originally here. Okay. So again, like I said here, you could choose to do else and tab these over, or you can just, because if the requirement is not to necessarily always have else, if you don't want. So we have if statement, and then if it's not one of these, then it will just execute this regardless. So we have this portion done. Let's go back and look at the instructions. So we have finished this whole entire section here. So now we got to look at how we handle object interaction. Before we do, we want to just check to make sure that all of these work before we move on. So I'm going to go ahead and print out the pet position. Because we know that in this it calls it, I want to also do display grid so we can see it each time. We're going to display the grid. Testing. Native Chelsea. We're going to do one. Now we have our new position here being 1 and 3. The original was 2 to 3. So when we use W, it moved up. Here it was originally. All right, the next one moved to the left. So we do see that it moved to the left. So that worked. Okay, now we're gonna look down and move down. So that worked. And then the next one we see it moved to the right. So that worked. And then the last one, it kept it exactly where it's at. So that's perfect. While we're here, I'm just gonna go ahead and show you how to fix this portion here. Now, this specific emoji, you know, throughout both semesters of teaching this, the emojis are the ones that it's nice and cool, but it also sometimes gives a little bit of problems. So with that specific emoji at the very top, it actually takes, if I'm not mistaken, 4 spaces. How you can fix that, especially as I've already used, where's the display function? Play grid. I've already used the left just align here, and that end spacing, it should work very well where that should not be a problem. So instead of actually, let me just comment that real quick. Instead of using that emoji, what you could actually use, since this takes up 4 spaces, is the bed with the person in it. That bed actually takes up 3 spaces, which should allow for this to work a billion times better. So let me run this. One. And there we go. So that section, it should be fixed now because this only takes up the normal emoji space, which I think is 3. So if you're running into that, you might just want to change the emoji at the top. I know I put that one in first, but I was checking at least with my code on my computer at home and I saw that it worked there, but didn't work here. And I recognized that it was just the emoji spacing here. So that's one fix. There are other fixes. I found that students have picked over time. It's just adding in spaces at the end of your emoji, or even just changing how you display it. So potentially using a different print statement here. Okay, so now that we've tested that part out in our move function here, we know that this works and it's great. And we've kind of already gone through the bed emoji function thing. And don't worry about this. It's just that's just the terminal. Um, we're gonna move on to the next part of it. All right, so in this section here, it says still inside of the move pet function, we're just gonna add a check after updating the position to detect what your pet stepped on. So if the new coordinate matches the food position, so we see coordinates again. So if the new coordinates match the food position, we're going to print out a message that the pet ate food. Then we're going to decrease hunger by 2, the minimum being 0, and increase the health by 1, the maximum being 10. And then we're going to call that respawn function that we created up at the right here at the top and relocate the food. So right now, I'm going to just start with this one, and then we'll move on to the other two because that's just going to be additional. It's not intense. So in this section here, and then here, this is where we're going to and hunger. So in this section, the first thing it says to do is we want to check to see if the new coordinates are in the same position as the pet position or the food position. So how we do that, if you remember when we were looking at this statement here where it says add the new row and column coordinates to pet position. It means we're going to be using this as a tuple. So in our if statement here, we're going to say if, we're going to have that tuple with the new row, new column, and then we're going to say if that is equivalent to the food position, meaning they ate that food and they like it, we're just going to go ahead and print it out. So I'm just going to use the same, think it was meat. Yeah. I'm going to use the same emoji image that I had there with the meat. And I'm just going to say, yum, some little message here. Your pet ate some food, explanation point. And then inside of here, what it asks us to do is, fluff it up. We want to print out that message, which we did. Now we want to decrease by 2 with the minimum value being 0. So if we're doing this and we want to decrease the hunger by 2 and we're going to reassign hunger, there are 2 functions that we can actually use here because we can still do our expression of hunger minus 2. But if we want to return to hunger, we could just use our maximum value. So in this case here, we'll update because remember, this is one of those global values we're updating is hunger. So we're going to say hunger equals, and we're going to use the max function here. This was supposed to kind of help bring out some of the stuff that you've already learned. And the original one says 0. That's the minimum value. But in this case, we're just going to decrease the hunger by 2. He's no longer as hungry as he was before. So out of these 2 items, it's just going to return the maximum value to hunger. So it was originally 5, and now it's actually going to be 3. And so it's slowly not going to be as hungry. And we're gonna do the same for health. Let's look at what that instruction says. So it says health. We're going to increase it by one with the maximum value being 10. So in this case, we're gonna, instead of using max, we're actually gonna be using min, and we're just gonna have 10 here, health plus one. So out of this, it returns the minimum value. You could just do health plus one, but you never know. You may want to add more to your gameplay later on if you want to use this for your project too. The next part of this here is it says for us to actually call the respawn function, right? This is okay, to relocate the food. So this was the original one that we did earlier where we kind of showed that it had multiple places where the food was. So we're just going to call a function. Hopefully you see the review in here. I'm going to call the respawn function here, and we're going to pass in the grid. And we're just going to respawn where the food is. So that is that first part there, and that's what it was asking from us to do. And some of the hints that you see in there, you could use. And the next part of this, it says, if the position equals the bed's location, print out a pet, print out a message and increase health by 2 up to 10. And with health, we're going to increase it up to 10 here. And then it says if the position equals to the toy location, print a message and increase happiness by 2 up to 10. All right. So we're going to go ahead and do that. So if you notice, it said if. So because we already have an if statement, we can use elif. So we're going to use elif. We're going to use the same new row, new column. And as you see here, we could assign this to a variable and just use that variable each time. I'm just going to do it this way, just because that's how I like to do it, so I know which one is which. But it's completely up to you. This is just my own feeling here. So we have here, if it's equivalent to bed position, okay. See the difference. So, okay. We'll just keep moving on for a moment. Um, So we have elif, the new row, a new column is equivalent to the bed position. Now we're actually just going to print out the position and say your pet is resting. So I'm gonna go ahead and put on that emoji. And if you really, really liked that other bed over the one with the person, you could add it in here as a statement. And you could say your pet is resting, dot, 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 plus 2. And then what we'll do inside of this statement here is we're actually going to assign to health. Oops. And we're going to use the minimum function here. We know that it's going to be either 10 or it's going to be health plus 2. And this is our expression here. We're just adding to the health if they're resting. Okay. And we're going to move on to the next one, and I'm going to just fix this in a moment. So the next one, we're going to do elif, and we're going to go ahead and check, make sure that we're using new row, column, and new column. And then we're going to say if that is equivalent, and it's probably going to be the same, toy underscore position. Then inside of here, we're going to print out, I believe the toy that I used, I don't actually remember that one. Oh, it was just the tennis, so I'll just use that. So we're gonna use this. Your pet is playing, explanation point, +2 happiness. And no, I'm not screaming, I'm just really happy. All right, and then here we're just going to have happiness equals, and we're gonna have that minimum function here. We're gonna put 10 and happiness. And because with these, it doesn't necessarily say you have to use minimum or maximum. You can use either or you want. And in this case, I'm just gonna use minimum for both because I believe 10 is meant to be the goal that we want for the happiest value, but right now this is where they're at. So let me just check the instructions really quickly. Okay, up to 10. Okay. So in this section here, and most of the assignments are meant to like kind of guide you to think about what is missing. So if, for example, at the very top of this function, and when we originally created it, it told us to use global variables, pet position, hunger, happiness, health, and food position. And then later on, we have to use bed position and toy position, but it's saying that it wasn't defined. And keep in mind, these are not variables that we used as global variables originally at the very top. In fact, they were created inside of the place object function here, which is why I said, make sure that you go through, overview the file to see if you understand or have any questions. So in this, we know that we use the pet position, we use the food position, but we did not use the bed position or toy position as yet. So in this case, where are we at? We see here that we are now checking bed position and toy position. What is something that we can do inside of this function to indicate that it is a global variable that we're using in this function? If you said add it to the global variable list, you're right. So one of the things that the global variable does is allows us to update those values, but it also allows us to use it as well. So in this case here, we're just going to do bed underscore position, comma, toy underscore position. And then also, okay, so we're going to also add it inside of the place object function here. So we're adding or modifying this to include that. So now when we go down to our move pet, we do see bed position and toy position. And we do see that we can use that now. Okay. So I'm going to save this and we're going to run this. Zoom in here, one, Robin. All right, and we're going to be using a step for loop here. Okay. And we see here just to, okay, our oops, you can't move works because it tried to move into that obstacle. This works. This also works because we were trying to move down. It can't work that way. And then we see, yes, it's updated it. We've also have our invalid move. And so we do see some of the functionality that we've added being there, but we've created this if else statement here without any form of understanding of at least like displaying it out. So now we need to move on to the next part of this so we can kind of see what all we need to add to it. So here, what we want to do is it says increase hunger by 1 every time the pet moves. So this is going to be applying these kind of natural states. So we're going to have our hunger variable that we know is going to be updated. We are also going to increase it by 1 with that maximum value being 10. So in this case, we know we're going to use the minimum function here. And then here we know we're going to decrease happiness by 1 every move that the pet makes, with the minimum value being 0. So we're going to use our maximum function so that it just does return the actual happiness that was there originally. Then we're going to check to see if the hunger equals 10. We're going to reduce health by 2, with the minimum value being 0. So we're going to use our maximum value here. And we're just going to print out a warning sign letting us know, hey, um, the red text is going to just indicate that the pet is starving or the health is dropping. All right, and then we're going to move on to the next step here. Okay, so for the very first one here, we're going to have our hunger and our happiness function or variables. For the hunger, I believe it said that the maximum value is going to be 10. So we're going to use the minimum function here. And then here, we're going to have hunger is going to be plus 1. So every time the pet moves, that is going to be increased by 1. And each time, for example, if it goes past 10, we're always going to make sure that it has up to that 10 value there. And in this case, happiness, we know that the minimum value is actually going to be 0. So as we decrease happiness by 1 every time it moves, it will not go beyond, or the happiness value will not go beyond 0, because for the maximum function, it's going to either return 0 or whatever value is here. So if this value was like -2, it's always going to return 0. If this value, for example, for hunger is 12 or 13, it's always going to return 10, because that is the value. Remember, with the range, it goes from 0 to 10 for each of them. So that's a way for you to kind of control the mechanisms of the game, but allow for it still to be naturally moving. So for this section, we finished that part, but we now need to add in that if statement that was required of us. So we said if hunger is greater than or equal to 10, we're going to set the health, and the minimum value is going to be 0. And we're going to decrease the health by 2 in this expression here. So we're passing in health minus 2 as a second parameter, this expression as a second parameter to the maximum value. So if hunger is like 12 or 13, health is going to be decreased by 2. And then we're also just going to print out some information. We're going to use F string here. So here I'm just going to have red. I have this warning symbol, not much. And we're just going to say your pet is starving, health is dropping, reset. Okay, save that. Okay, so the nice thing that we're going to do is the very last item on that list, which is number 7. Well, I think we have a few things to fix up with main, which is just the moving mechanism, the directions. So we're going to first start with, we're going to call display grid to show the new grid layout. We're going to display the status of the pet to update the pet hunger, happiness, and health. So that's fairly easy. We're just going to make a function call. So we're going to display grid function, passing in the grid. And we're just going to do display status, passing in the pet symbol and also the pet name. And all right. So now that we've finished with this section here, we're actually going to move on to the main so that we can stop using this testing part and just actually create our own um, user interaction here. Go ahead and look to see what main is requiring of us. So we're going to scroll down to the main function, which we've already done. Then we're going to keep the intro and the setup line. So we have our call to the user instructions, prompt the user. That's going to return our pet symbol, pet name, create the grid. That's going to return the grid, place the objects. We also have our generate grid function as well that's in there. After displaying the grid and the status once, which is what the beginning part of main does, we're going to create a while loop that's going to just keep on running. So in this case here, we know that we're going to potentially just be using while true, and we're going to have a break because it's just going to keep on running. Then inside of the loop, we're going to prompt the user player to enter in the move WASD or Q to quit. So that Q is probably going to be used for us to end this while loop. We're going to have a break. So we might need to have an if statement, which the next line, it does say that. If they enter Q, print goodbye message and end the loop. So we're going to use break. Otherwise, again, you can use else, or you can just put this underneath the if statement. Call the move pet function, passing in the move. So if we see here that this is a move, and we know that the move pet function takes in, where's that? Takes in a direction, that means that the variable that is going to be assigned to this statement here is going to be called move. We're going to pass in grid and the pet symbol and the pet name. And then we're going to check to see if the health is 0 or less. Then we're going to print out game over message and end the loop. So this is also going to have a break statement here. So in this, we're going to go ahead and use some of the code we already have. We're just going to change I to move. And up at the top here, we know, just tap over, we're going to be using while, and we're going to have true. Okay. So we have our while loop. The next thing we need to do is we're going to have our variable move. Now that works there. We're going to use input, and we're going to prompt the user, enter a move, and we're going to put W, A, S, D or Q to quit. And if you remember what I stated earlier, when we were going through the move function, oh yes, here. Whenever the user enters in information, that is what's going to get passed in here. So if they enter in a lowercase w and you don't control that input from the user's standpoint, then this is going to throw an error. So whatever you have here, if it's lowercase w, make sure you do dot low or dot strip. If it's uppercase w that you're using, make sure you use dot upper dot strip. This is just to control the input from the user. So if they put W and then put a space here and then press enter, that could give an error as well. So we want to use the upper function and we also want to use the strip function so it can relate better with our code. Now that we have that line where we're asking the user to enter an input, the next thing we're going to do is we want to check first if they even press Q to quit. So if the input from the user, which is stored in the move variable, is equivalent to Q, which we're using uppercase here. If you're using lowercase, make sure you make Q lowercase. Then we're going to print out a message. I'm going to use F string here. Wave. And then thanks for playing, explanation point, open, close, curly braces, and we're going to just put the pet name. And in the main, again, I named that PN. But you can name that pet name. And in fact, it would probably be better to go back and just make that the same all around. I'm going to go ahead and do that. Name. We have moved on past this, so we're going to do this right. Well, just remember, it does not have to be the same name, but in terms of the variable naming, whatever is in main is local to main, unless we're using that global variable. I just want to reiterate that. So we're doing pet name, the symbol, pet name here. All right. Okay. So we've modified the pet name. We're printing out this information. We also want to finish this up. I'm going to just say, um, miss you. Right. And then afterwards, because it's Q to quit and this while true is going to keep on going, we're going to do break. Now, again, some people might find that this is actually not the best, so I will actually show you the Boolean flag here. But it depends on your programming style and whatever that professor is requiring of you. While true works perfectly fine, and we're going to use a break statement here. But we could use a variable that we store true in and then just reassign it here and use break as well. Either or should work. So in this case, we have our print statement, we have the break, so we have the if the person prints Q to quit, we have that statement down peg. Now the next thing we're going to be looking at is otherwise. We called that, we already have that call. Now we're going to be looking at if health is 0 or less. So that means we're going to be using less than or equal to. We're going to print game over, message, and end the loop. So we're leaving this grid alone. But what we're going to be doing in here, and we'll get rid of this because we want to call it elsewhere. Now we're going to put if health is less than or equal to 0, print f, just going to do red, And here we're gonna do like a ugh, very dark, gruesome, dead, and then say, oh no, pet name has, well, this is really sad, passed away. And then game over. Let's hope it does not get to that. Reset. And then afterwards, because this will also end the loop as well, we're going to put break there. So in this case here, this is what this function is requiring us to do. And everything else, it fits perfectly fine. It works well. And lastly, since we've kind of already went through this in the code with me, I'm just going to show you this. So this is pretty much just the entry point of code. This is just going to be, by default, it's like hidden behind the scenes. It's assigning this, expressing that this is the main function that we're going to be running here. Um, but this just allows for another file import to use this code, and the game pretty much won't auto start unless this is ran. So this statement you'll find quite often. Either or, this works the same. You could just do main and comment this out, but this is one of those formal writings. If this hidden attribute is equivalent to main, then we will want to run that main function here. Let's save this and everything else is finished. Okay. Last thing before I run this and test it out, if you wanted to use a Boolean flag, then you'll say is true. Here you create a function and you set it to true here. You can literally just do while is true, and then below here when you have break, you just say is true and you set it to false. Break, and then below here you have is true and you set this to false. So that does the same thing as just doing true. But this is what we call a Boolean flag. It just stores the Boolean in a variable and you can reuse it below here. As I'm teaching, I kind of prefer to just go ahead and use the true tip so you can see how that works, but either or works as well. So true. Okay. All right, so we're going to save this and run this and test this out. And then let me just do cat. We'll do, okay. First things first, we have Penny in between two objects here. So we're going to test out to see if Penny hit the obstacle W. Okay, so yes, oops, you can't move there. Penny didn't move. All right, so then we're also going to then move left. And if you remember when I said if I had like a space there, it should still work because we did strip. So yes, it moved, I'm sorry, not left, right. We're moving D and it moved Penny to the right, updated it. So we are seeing Penny being a little bit hungry. So we're going to keep moving over and down. All right, so Penny ate and the status changed. Went from being hungry 7 out of 10 to now being 6 out of 10. But that happiness level is extremely low. So I'm gonna go down some more, and then try to get them to play. Okay, they're happy by one. That's all good. And then let's try to get Penny some rest. Oops, D. Please don't die. No. Right. Well, my pet died. Oh, that's really sad. Anyways, my pet died, but this is how the process should look like. Please let me know if you have any questions, and I hope you get further along with your pet than I did. Anyways, have a great rest of your day and take very good care of yourself. Bye bye.